Hi friends, today we're going to talk about exponent rules. Now before, in a previous video, we talked about evaluating an exponent when it looks like something maybe 2 to the third power. So this would be 2 multiplied by itself 3 times. So 2 times 2 times 2, which is equal to 8. Now, that's great, but sometimes we have to get a little bit more complicated than that, and so we have some rules to help us handle it. I'm going to write the rules up here, and then we'll talk about what they mean. So, the first rule that we have tells us how to multiply when we have 2 things with the same base. So that base of A, that could be any number or a variable. But the important thing is that they are the same base and they each are raised to an exponent. So in that case, our rule tells us that a to the m times a to the n is equal to a to the m plus n power. Now let's look at an example of what that might be. So if I had 3 to the 4th power multiplied by 3 to the 2nd power, this would be 3 to the 4 plus 2 power, which would also be 3 to the 6th power. This makes sense because if I were to write out all of those 3's, which I'm going to do for this one, but I won't be doing for the other examples, I would have 3 times 3 times 3 times 3 for that 3 to the 4th power, and then 3 times 3 for that 3 to the 2nd power. Let's use some color here. Okay, so I've just marked those 4 3's on the bottom to indicate that they came from the 3 to the 4th power, and the 2 3's on the bottom to indicate that they came from the 3 to the 2nd power. And if I were to count those up, I have 6 3's multiplied together, which is another way to say 3 to the 6th power. Now, usually, almost always, we're not going to want to write all of that out because it's not convenient, it takes us too long, and when we're dealing with variables, it may not even be possible. So we have a rule to tell us how to evaluate it. All right, let's look at another rule for evaluating exponents. And that's going to be when we divide and we have the same base in both the numerator and the denominator, and they're both raised to a power. So if I have a to the m divided by a to the n, our rule tells us that this would be a to the m minus n power. Again, let's look at an example of what this might look like. So let's say that I had 5 to the 3rd power divided by 5. Now, remember that when we don't have an exponent here, the exponent's assumed to be 1. And I call this a sneaky one because we can't always see it, but it's always there. So 5 to the 3rd divided by 5 to the 1st power, our rule tells us that this would be 5 to the 3 minus 1 power, which would be 5 to the 2nd power. Let's look at this another way by writing it out, just like we did with our 3's up here. So if I had 5 to the 3rd, which is 5 times 5 times 5, and it was going to be divided by 5 to the 1st power, remember, our fractions tells us that we can cancel when we have the same number in both the numerator and the denominator. So I'm going to cancel one of those 5's in the numerator with one of those 5's in the denominator. And that's going to leave me with 5 times 5 in the numerator, which is just 5 to the 2nd power. I have one more rule to put up here. And that is going to be my power to a power rule. So if I have a to the m power and it is raised to the nth power, this is going to be a to the m times n power. Now let's look at an example of that one. I'm going to take it right up here to the top of this board. So if I had 2 to the third power, and that was squared. So 2 cubed, then squared. Well, our rule tells us that this would be 2 to the 3 times 2 power, which would be 2 to the 6th power. But let's write it out. So I want to start with 2 to the third power. This would be 2 times 2 times 2, except we're squaring it. So that would be multiplied by itself, 2 times 2 times 2. So 2 to the third power, I have 2 of those. So this would be 1, 2, 3, 4, 5, 6 2's, which is 2 to the 6th power. All right, so those rules allow us to evaluate some exponents in a fairly efficient way. We can use them if we're working with numbers or if we're working with variables. So let's look at a couple of examples, and then we're going to add in some parentheses just to make it interesting. All right, let's say, what if I had x to the third times x to the 6th power? Well, we have the same base on both of these. It's an x. Now, I don't know what x is, but I know that the bases are exactly the same, whatever x is equal to. So my rule over here tells me that when I multiply the same base, I add the exponents. So this would be x to the 3 plus 6 power, also known as x to the 9th power. All right, let's try another one. What if I had y to the 4th power over y squared? So this would be y to the 4 minus 2 power, which would be y to the 2nd power, or y squared. And of course, that's using this rule here for division when we have the same base. And when we do have that same base and we divide, we subtract their exponents. All right, let's look at another one involving variables. If I have z cubed and I raise that to the 4th power, now it's going to be entirely too many z's, but let's figure out exactly how many there are. This would be z to the 3 times 4 power, and I just use this rule right here, which tells me that when I raise a power to a power, we multiply those exponents. So we could write this as z to the 12th power. Okay. When we make this a little more complicated, we would be adding in some coefficients there and adding exponents on those coefficients. So in the next video, we're going to run through some examples that apply these ideas in a slightly more complicated way. So come back and watch that video as well.